Welcome back. Have you ever wanted to send a production database straight into the seventh circle of Dante's Inferno, making your company lose tons of money and land on the front page of every news outlet? Well, let's hope not. That would be a disaster. In today's video, we're diving into data management, working with JSON data and SQLite? SQL? Sequela? SQLite? Oh yeah, I think that's the one. Databases. These two topics go hand in hand because both are essential for storing and retrieving data, a key part of modern development. We'll start by exploring JSON, not to be confused with this JSON, whoever he is. Our JSON is a lightweight, flexible data format that's incredibly easy to use in Python. Then we'll connect to an SQLite database and walk through the essential CRUD operations, creating, reading, updating, and deleting records. First, let's talk about JSON, or JavaScript Object Notation. JSON is a lightweight format for storing and exchanging data. It's widely used in APIs, configuration files, and more. Here's an example of what JSON looks like. In Python, JSON data is treated like dictionaries, making it easy to parse and manipulate. Let's see how we can work with JSON in Python. Python's JSON module makes it simple to work with JSON data. Let's start with loading JSON from a string. You can also write JSON to a file. And to read JSON from a file, the JSON module provides all the tools you need to work with JSON, whether you're dealing with strings or files. Sometimes JSON data is more complex, with nested structures. Let's say we have this data. To access nested data in Python, also, if you want to convert a Python dictionary back to JSON, we are using json.dumps to convert a Python dictionary into a JSON formatted string. Let's break down the arguments. Python dict, the object to be converted. This is a standard Python dictionary. JSON.dumps takes this dictionary and converts it into a JSON formatted string. Indent equal 4, pretty printing the JSON. The indent parameter specifies how many spaces should be used for indentation. It makes the output more readable by adding line breaks and indentation instead of keeping everything on a single line. If indent is omitted, the JSON string will be compact, no extra spaces or new lines. There are other optional arguments, not in your code but useful. This one controls how items are separated. This sorts dictionary keys alphabetically in the output JSON. And this last one allows non-ASCII characters, for example, to be preserved. Now that we've worked with JSON, let's move to SQLite, a powerful and self-contained database engine that's widely used in applications, ranging from mobile apps to embedded systems, unlike traditional databases. SQLite doesn't require a separate server, it stores data in a single file, making it easy to manage and highly portable. We'll use SQLite to store and manipulate structured data, just like we did with JSON. Let's start by connecting to a database. To work with SQLite databases in Python, we use the built-in SQLite tree module. The first step in our code is to establish a connection to the database using. This command does two things. If the database file doesn't exist, it creates one. Otherwise, it simply opens the existing database. With the connection established, we then create a cursor using connection.cursor, which serves as a tool for executing SQL commands. Think of it as our database operator. It allows us to send instructions like creating tables, inserting data, and retrieving records. Once we have the cursor, we execute a SQL query to create a table if it doesn't already exist. The command inside cursor execute defines a table named users, which consists of 4 columns: ID, name, age, and skills. The ID column is an integer primary key, meaning it will uniquely identify each user and automatically increment with every new entry. The name column is of type text, suitable for storing names, while age is an integer. The skills column is also of type text, but since skills are typically stored as lists in Python, we'll later explore how to store lists properly in a database. After defining the table structure, we commit the changes using connection.commit. This step ensures that our table creation is saved to the database, otherwise any changes will be lost when the script finishes running. Finally, we close the connection with connection.close. Closing the connection is important because it releases resources and prevents potential database locks or corruption. With this setup, we now have a working SQLite database and a properly structured table. So far, we've covered the basics of storing and managing simple data types like text and numbers in SQLite. But real-world applications often require handling more complex data such as lists, dictionaries, and nested structures. Since SQLite doesn't have a native list or dictionary data type, we need to find efficient ways to store and retrieve this kind of structured data. A common scenario is storing a list of values, such as a user's skills. If we try to store a list directly in SQLite, it won't work, because SQLite only supports basic data types like text and integers. Instead, we can store the list as a JSON string and convert it back into a Python list when retrieving it. Here's how we insert a list into the database. The key here is JSON.dumps, which converts the Python list into a JSON formatted string. This way, SQLite can store it as text. To retrieve and convert it back into a Python list, using json.loads, we transform the stored string back into a usable Python list. Sometimes we need to store structured key value data, such as user settings or configurations. SQLite doesn't support dictionaries natively, but we can store them as JSON, just like we did with lists. For example, let's store a dictionary containing user preferences. Later, we can retrieve and use this dictionary in Python. This method is useful when working with user settings, API responses, or any structured data. While storing dictionaries as JSON in SQLite is convenient for unstructured data, such as API responses or logs, it's not ideal for structured data. For example, if user preferences are unique for each user, we can just do this, but if they are all the same for each user, we shouldn't do it. A challenge with storing JSON data as text in SQLite is querying individual elements inside a list or dictionary. Since SQLite 3.38, JSON functions are natively supported, making this easier. For example, if you want to find users who have Python in their skill lists, this works because JSON is stored as strings and we can use the like operator to search inside it. However, if you're using SQLite 3.38 or later, you can use JSON functions. This extracts the first element of the JSON list and checks if it's Python. We used like in the first example because it's easier to explain and works in simple cases, but it's not the most reliable way to search within JSON data. A better approach is using SQLite JSON each function, which treats JSON arrays as table-like structures, allowing us to search each element properly. This ensures we don't miss matches due to formatting differences. For example, this checks every item in the array, making it more accurate than just extracting the first element with JSON extract. Although storing lists and dictionaries as JSON can be useful, in some cases, relational databases are better suited for structured data. If users can have multiple skills, a better approach is to create a separate skills table and use foreign keys. Instead of storing skills as JSON string, we create a separate table. Now we can store user skills as separate rows instead of a JSON string. We can query skills separately and find users based on specific skills. This approach follows best practices, improving query performance and making data easier to manage. While storing data as JSON works well for simple use cases, like I said before, relational tables are better for complex queries. Use JSON storage when the data is small and doesn't need frequent querying, the structure of the data might change over time, or you're working with an API that already provides JSON data. Use relational tables when you need to query, filter, or join data efficiently. You have relationships between entities, for example, users and their skills, and you want to enforce constraints like foreign keys. Now, let's go through the 4 basic CRUD operations: create, read, update, and delete. To add data to our users table, we use the insert into statement. In Python, it's best practice to use parameterized queries to insert values securely and avoid SQL injection. Here's how we can add a new user. This script connects to the database, executes an insert statement to add a new user named Alice, and stores her skills as a JSON string. After executing the statement, we commit the changes and close the connection to save resources. Once data is stored, we need a way to retrieve it. The select statement allows us to fetch records from our table. Here's how we can retrieve and display all users in our database. When executed, this script prints all records from the users table. Each row is a tuple containing the values of the respective columns. This approach helps us inspect stored data before making modifications. Updating a record allows us to change existing values while keeping the same database structure. Suppose Alice had a birthday and we want to update her age. This script locates Alice's record and updates her age to 31. The where clause ensures we modify the correct record, preventing unintended updates to multiple users. Sometimes we need to remove outdated or unnecessary records. To delete Alice's record from the database, we use the delete statement. This query removes the user named Alice from our database. The where condition ensures only her record is deleted, preventing accidental data loss. These 4 operations, create, read, update, and delete, form the foundation of working with databases. With these, you can now manage and manipulate stored data efficiently. Now that we understand both JSON and SQLite, let's bring everything together into a real-world example. Imagine you're working with JSON data, maybe from an API or a configuration file, and you need to store it in a structured way inside a SQLite database. We'll take a JSON dataset containing user details and insert it into our users table. We start with a JSON string representing a list of users, each with a name, age, and a list of skills. Here, json.loads parses the JSON string into a Python list of dictionaries, making it easier to manipulate. Now, let's connect to our SQLite database and insert this data. Each user dictionary from our parsed JSON is inserted into the database. The skills list is converted into a JSON string using json.dumps before storing it, ensuring SQLite can handle it as a text field. Let's retrieve our stored data and convert the skills back into a Python list. This ensures that when we retrieve the skills data, we can convert it back into a usable Python list using JSON.loads. Why is this useful? This method is extremely practical when dealing with real-world scenarios like APIs returning JSON responses that need to be stored in a local database, configuration files that store settings and need to be parsed into structured data, user data management where attributes like skills or preferences are lists or nested objects. With this approach, you now have the ability to seamlessly store, retrieve, and manipulate JSON data in SQLite, making it easier to integrate databases into your Python applications. Throughout this video, we explored the essential skills needed to handle JSON data and integrate it with a SQLite database. We started by understanding how JSON structures work, how to parse and manipulate JSON in Python, and how to store JSON formatted data inside the database. From there, we set up a SQLite database, created tables, and performed CRUD operations, adding, retrieving, updating, and deleting records. You should have a solid grasp of how to bridge the gap between structured data and database management. Now, here's your challenge. Find or create a JSON file, store its data in a SQLite database, and experiment with different queries. Try retrieving specific data, updating records, or even structuring more complex datasets. This hands-on practice will reinforce what you've learned and prepare you for real-world applications. If you found this video helpful, hit that like button, subscribe, and drop a comment below. Whether it's a question, a challenge you faced, or an idea for a future video. Happy coding, and I'll see you in the next dimension.